Good morning, everyone. Welcome to this EeB-CA2 Energy Performance Monitoring and Management webinar. So this is the first webinar of the 7 webinars we organize for each technology working group. So just to remind you what EeB-CA2 consists in, so actually it's one of the 4 CSAs dealing with energy efficient buildings. And our activities include to organize some clustering workshops to establish synergies between the EeB PPP projects. We also offer some dissemination opportunities, such as participating to international fairs. We also organize some trainings and webinars, such as the one today, to help you transfer your technologies. And we also offer a set of online tools and services to enhance visibility on the projects. So today, the agenda for today's webinar. So we will hear a presentation by Roberto Fredizzi from URAC, who is coordinator for the INSPIRE project. So he will present us the technologies that developed in the framework of this project. Then we will have a question and answer time with the audience. So I will be the moderator for this session. You will be able to raise your questions or to bring your comments. And then we will have a short conclusion by my colleagues from EeB-CA2 about the services we offer within EeB-CA2. During the webinar, I kindly ask you to mute your phone so that we avoid having disturbing noises during the presentations. For the Q&A session, you will be able to raise your hand on the button on your screen, and I will give you the floor when I see your hand. And I will share also the PowerPoint presentations after the webinar. So these are the participants for today. Yeah, that's it.
Yeah, today I will talk to you about the project INSPIRE that we recently finished, actually 1 month ago also. The idea on the one hand is to talk about the project itself, bringing in some experience we had in the project during the project elaboration. On the other hand is to show you a couple of examples of the the technologies that we developed through the project, and again to give you a little flavor of the main lessons learned that we learned at the end of the project, through the project, and at the end, and that I thought it could be interesting to share with you and to listen your feedback about. So the project, how do I progress here? Like with the arrows? Yes. Okay. Good. Then the project was a quite big one, with an 11 million euros budget and 24 partners that you see named or listed in the slide, and the duration was 4 years. As I said to you, we recently finished. The objective of the project was to look at the energy retrofit of existing buildings, both residential and office ones. Even though, as you will see in a minute, we concentrated on the residential sector. And what we wanted to do is to not only look into the envelope technologies, which is state of the art already, but to also look into energy generation and energy distribution into the buildings themselves, which is a little less well established as a practice. Again, aim of the project was to reduce the energy consumption, primary energy consumption of the buildings, taken into consideration from the actual status, from the actual level down to lower than 50 kilowatt hours per square meter in a year, which is kind of a level the European Commission considers for for a building to be named a nearly zero energy building. Together with this, we had another objective, which was to reduce the lighting consumption, energy consumption by 50% compared to the actual status, to the status before renovation, so to say. What we did is basically to go through or try to reach these objectives following two ways. On the one hand, we wanted to develop what we call these renovation packages, which are basically the solutions that you should take into consideration when you want to renovate a building in terms of envelope, generation and energy distribution systems for different typologies of buildings and for different climates. Therefore, this is kind of a set of measures that you should take into consideration if you want to reach certain energy levels, energy consumption levels after retrofit. We knew already from the beginning that this is something already done in many projects and in the past also. And we already knew during project proposal phase that the main limitation of this solution is that then you have to implement them on the site, and that is not so easy. Therefore, what we wanted to do is also to develop some renovation kits, what we call kits, which is, by the way, prefabricated technologies that you can use to facilitate the application of or the implementation of the renovation packages or the renovation solutions, because most of the problems that you can find on site are already solved during prefabrication, during the industrial phase, during the industrial fabrication phase. So this is it. Just to summarize how the project was organized. Looking into the first topic, the renovation packages, what we did is to basically start from the analysis of the building stock in Europe. And this is because there is really much information available in the open literature, but that is very spread and split into probably too many documents. And again, it is not really well organized and structured. So what we did is to look into what is available in the literature and to set it up into a database that is now available on the website at the address that you can see on the slide, and that you can use to on the one hand to look into how much typical buildings spread around Europe for different climates are consumed before renovation. So how typically a building consumes in Europe. But why we wanted to do to organize all this information into a database is also because we wanted to understand what could be the impact of using certain technologies and certain renovation solutions on the overall building stock. Therefore, on the one hand, we wanted to know the starting point, to understand how much you can save on a typical building. On the other hand, we wanted to understand what is the impact of using certain renovation packages, renovation solutions, as we call it. What we noticed very early in the project is that there is quite a lot of information, not very structured, as I said, but there is really much information which is lacking. And for example, I refer to cooling demand, space cooling demand, and I refer mostly to the office sector, where the knowledge on the energy uses even for lighting, but also for, I don't know, heating and cooling, space heating and cooling, they are really missing for many of the European member states. So basically, we structured this information into this database. It is nothing else than an Excel sheet, so nothing complicated to handle. Is that we have many holes that we wanted to cover to complement. We wanted to complement the literature available information somehow. And to do this, what we did is basically to go through simulation work. So basically, we individuated a number of construction typologies around Europe, from single-family houses to multi-family houses to office buildings. I didn't report all here in the slide, but just for you to have a flavor again. You see a single-family house and a multi-family building. What we did is basically to use the available information in terms of wall constructions and climate and users' behavior, ventilation, ventilation habits, and so on and so forth for the buildings and different typologies, again, in different climates and different countries in Europe, to run the simulations applied to these buildings. And what we did is basically to then use the demand and energy. Sorry, I hear a lot of noise in the background. I do not know if everybody could switch the microphone off.
Yes, I kindly ask everyone to mute your phone to avoid these noises, please. Thank you.
Thanks.
And I mute again myself.
Thanks, Sinclair. Yeah, thanks. I'm sorry, everybody. So what we did is to run these simulations on these what we call reference buildings, and what we did is to use the information that we generated in this way to complement the missing data out of the literature review. So now we have a quite comprehensive understanding out of how the existing buildings work around Europe, and what we did is basically then to run simulations how to use envelope solutions, so insulation and windows, and how to use different generation systems, including heat pumps, biomass boilers, gas boilers, solar thermal PV panels, and distribution systems, including radiators, radiant ceilings, fan coils, and so on and so forth, to renovate, to retrofit from the energy point of view, the building, the different reference buildings that I mentioned before. So again, what we know now, or what we did now, is to include the results of quite an extensive parametric analysis with more than 500,000 combinations in the end, I think, into another database that you can again look into at the same address, where for different climates, different reference buildings and ages of construction, I forgot to mention before, you can understand which are the different, you can understand which are the results associated to specific retrofit solutions that you can adopt, both in terms of energy performance and in economic performance. So from the energy performance point of view, what we did is to basically present final energy, primary energy consumption, efficiency of the generation systems, both in terms of thermal efficiency for biomass and gas boilers, and seasonal performance factors for heat pump-based systems. And again, we try to also look into how much this solution could cost in terms of investment, upfront investment, and then operation and maintenance cost through the lifetime of the system. I don't want to go through too much through this data because, as I said, the database is huge. But again, you can try to go through that on the website or download it from the website, and then eventually, if you have any questions or any remarks you would like to discuss, we can discuss it directly in a bilateral phone call, for example. This said, again, I mentioned already at the beginning that when you try to go through this kind of renovation measures for any kind of building, measures that include, again, insulation, windows, ventilation, heat pumps, solar collectors, this new distribution system, and so on and so forth, you can understand that most of the time that kind of measures are quite complicated for installers to be implemented, set up, first of all. But before that, they are quite complex also for energy planners and architects to handle, because that is not usual practice, as I said. When we go on site, they are quite high invasive and last quite long, which is a discomfort for the inhabitants of the houses or users of the offices. And finally, and one of the most important points, they are quite expensive from the investment cost, initial investment cost point of view. Therefore, even though the technology or the solutions are there, and the single technologies are there on the market, available to be implemented, basically this kind of deep retrofit approaches or deep retrofit measures are almost never taken into considerations. And people just go for easier solutions, changing or adding new insulation, changing windows, and eventually changing the single dwelling gas boiler, for example, in southern countries, and that's it, because that is easy, affordable, and people know how to make it. And this is a loss of opportunities, by the way, for these people that are intervening on their buildings, but also for Europe, because we are losing time and opportunities in terms of reaching the goals, the 2020 or 2039 now goals. So what we wanted to do is to give the stakeholders in the construction process, starting from architects, going through energy planners, installers, and then arriving down or up, depending on the point of view, to the users. We wanted to give them, all these people, technologies that facilitate the implementation of the retrofit measures. And again, what we did in this sense is to concentrate on the residential sector, and what we did is to concentrate basically on two demonstration sites. And we tried to, first of all, to be really pragmatic, or to adopt a pragmatic approach. We tried to develop the technology solutions around these two demo cases, and then to verify if this technology solution could be adopted outside or in a broader way. The two demo cases that to be again really direct, that we looked into are one multifamily house that you see here on the slide, which is located near Stuttgart in Ludwigsburg. It is the first neighborhoods of Stuttgart. And then the second one is a multifamily house that again I will show you later on in the presentation, located in the neighborhoods, in the popular neighborhoods of Madrid in Spain. So again, as you can see here in the picture, this is a small multifamily house with 4 floors, including the attic and a cellar floor, which was built in the 60s, 70s, and then partially renovated already in the 80s with the new windows and new a little insulation, something like 4-6 centimeters insulation. This standard was not anymore reasonable or suitable for the Wohnungsbau Ludwigsburg, which is this social housing company that owns the building. So they wanted to go for a better construction typology in the end, and therefore what we did with them is to look into how to renovate the envelope, and also how to renovate pipelines for space heating and domestic hot water distribution. And we looked into how to retrofit or to add a ventilation system to the building. And a must for them was to have the inhabitants, the tenants, living into the building while the renovation work was ongoing. And as a consequence, you can easily understand that the needed choice was to work on the existing facade, on the external surface of the existing facades, to install ventilation system and pipelines. On the right side of the slide, you see the building, a render of the building with the horizontal pipelines that we installed before as a first measure to renovate the heating and cooling system. Basically a plumber installed the pipelines onto the facade. And then on the left side, you see on the other end the complex ventilation system that we wanted to install. The system is complex even because in our research project we wanted to test different ventilation solutions. So on the ground floor we have a ventilation machine which is installed outside the existing facade into the new facade, into the new insulation, and I will show you in a minute how it is made. But the distribution of the fresh air is made inside the dwelling. On the second floor, on the other end, we have a ventilation machine, which is again installed in the new facade element, but the ventilation distribution is completely executed or installed into the new facade, into the new insulation, while there are no duct lines inside the dwelling. And finally, we have another solution in which is the attic floor that you see, in which we have a centralized ventilation machine which is installed in the cellar floor, in the technical room, in the cellar floor. Air is distributed and taken through the vertical light blue shaft that you see in the picture, and then again it is distributed inside the dwelling, inside the attic floor. As I said before, all these pipelines and ducts are installed outside the existing envelope to minimize the discomfort during installation for the tenants. And again, duct lines, the pipelines have been installed on the facade. The ducts for ventilation, they have been installed during the prefabrication process of the insulation elements. Again, insulation is not a normal one. It is a prefabricated wooden frame facade element, which is anchored to the existing facade, as you can see here on the render again. Basically, this element, maybe you can see even better in this representation. Yes. The wooden frame element, you see a picture on the bottom left, is basically an industrial prefabricated element which includes also windows and insulation. And as you can see here in the picture again, in this case, you have the space available for the installation of the ventilation machine that you see on the right side picture, and of the ducts that you see reported or shown in aluminum on top of the windows in the bottom picture. So basically, the construction process is that you install the pipelines, and then you wrap everything up with these prefabricated wooden envelope elements during the construction process. Here you see some pictures of the relating on the installation of the pipelines. Here in the small pictures on the right side, you see the horizontal pipelines installed on the facade before on the existing facade. On the left side, you see the vertical shaft that connects the horizontal pipelines to the technical room, which is again placed in the cellar floor. By the way, here we installed an air-to-water heat pump driving both space heating, or providing both space heating and domestic hot water. And here again, in the same shaft picture and in the two central pictures, you see the hydraulic boxes that have been installed to connect the single dwellings, domestic hot water and space heating to the central system. To install all these pipelines, what we did is to use the staircase, which is a quite common and useful solution, because this space or this volume is quite, or most of the time, underused or exploited normally in all buildings. So there is quite some available space to install active elements, and that is quite useful because if you have some elements like this hydronic unit that you see on the right side, and you need to inspect them and to maintain that during the lifetime of the system, then this staircase position is quite comfortable for the maintenance people. Going back to the prefabricated wooden envelope elements, I already explained to you. They come in a height which is equal to the height of the single floor, and they cover the entire length of the facade of the building, one facade of the building. Here you see again duct lines, windows, and insulation already pre-installed during the fabrication phase. These elements, as you can see in the picture, are brought on site as a single element, and anchored to the existing facade, wrapping up the entire building. So basically, this is the result. Starting point on the left, upper left side, and ending point bottom right. As you can see, a main architectural change was, which is not only architectural by the way, was to move the balconies of the ground and the first floor from the south-facing long south-facing facade to the short west-facing facade. This is a big change from the architectural point of view, but was needed also from the technical point of view, because we wanted to, with this building, we wanted to reach the passive house standard. So we wanted to go below 20 kilowatt hours per square meter and near space heating demand. And to do this, we needed to cut as much as possible the thermal bridges, and the balconies were one of the main bridges we encountered, and therefore we decided to completely cut the old balconies, close or wrap up again the building inside the thermal envelope, and then to build this small castle with the new balconies on the west facade. Again, why we needed to cut the balconies and go straight is one of the main limitations with this prefabricated wooden facade, which cannot be shaped in any kind of angle that you can imagine. And again, as I said, this is an issue when you work with these prefabricated elements. For you to know, the design phase was very long because we had because this was a research project, but we needed also to structure quite a lot the work together with the architects, energy planners, and installers in the project. So, and this took quite a lot of time, but the installation phase was very short, very straightforward. So the entire building was renovated in a couple of months, for you to know, with people living into the building itself. Quickly, the second building, that is a multi-family house, a bigger one, 5 floors, 10 apartments, located in Madrid. The building was quite in a bad status during the before retrofit, with a lot of structural problems and cracks both outside and inside the dwellings, as you can see in the pictures. So basically what they did, what the municipality Madrid did, first of all, is to work on the reinforcement of the structure. And to do this, first of all, they built this, or they embraced the entire building with a metallic structure connected to a new foundation all around the building. And then they built also this shaft that you see on the left, which is again which has both structural reinforcement purposes, and it also enticed the new lift, which is installed, which is now available. For you to know, again, one of the main lessons learned is that due to the fact that the population in Europe is elderly, to add these kind of solutions, which were the lift, so to say, to add a lift to the building, which was not available before, was one of the main reasons why the owners, in this case they are single owners, 10 single owners, why the owners accepted to go for the energy retrofit. So it is not energy, the initial point of view, it is a better, more functional building. So this is how it looks now inside the building. with a new staircase and lift. The retrofit of the envelope of this building was made outside the Inspire project, because that is quite a common solution, with rock wool, 10 centimeters of rock wool installed on the facade, new windows flash mounted in the insulation, and on top of the existing windows, which are still there. So there are 2 levels of windows available now, and they also insulated the gap between the ground floor and the ground with some polyurethane insulation foam. So this typical retrofit was not part of Inspire. What we did in Inspire is to retrofit the heating and cooling system. So basically, what we wanted to do here is to install a new, starting from one step behind, what they had before retrofit is single gas boiler, electric boilers, and butane boilers. It was really different solutions to produce domestic hot water, and only in some cases space heating. What we wanted to do is to improve much without them to spend more in terms of energy bills. Therefore, what we did is to work on the installation of a air-to-water heat pump system, driven also by solar thermal collectors. And again, as you can imagine, since we didn't have enough space on the ground floor to install this kind of system, the gap between ground and the first floor is 1.5 meters, so to say, for you to know. What we did is to use again the lift shaft structure that you see here on the right side picture to install the technical room. So this is a very well reinforced element that also allows to bear quite some heavy. So we decided to have on top of the roof, on top of the lift shaft, also the technical room. Here you see in the central picture how we distributed pipelines for heating, cooling, and domestic hot water into the dwellings. And basically, again, we use the lift shaft to connect the technical room to the single dwellings, and we distributed fluids through the staircase again into the single dwellings. Here on the right side again you see the heat pump, the air-to-water heat pump we installed, and the solar thermal collectors, 22 square meters, I don't remember exactly, that are vertically installed on the parapet of the building itself. Once again, this installation is quite complex for normal installers, and as we worked together with an energy planner for planning the system, the heating and cooling system, I can tell you that it was not really straightforward for them to develop the P&I, the layout of the system, and to size the components. Not to talk about the control of the single actuators like valves and pumps. So knowing this, what we did through the project is to develop what we call this energy hub, this prefabricated generation solution, which is nothing else than this hydraulic box that you see in the central pictures, which includes basically valves, pumps, and control. What this hydraulic element does, in addition to normal hydraulic elements, normal hydraulic boxes that you can find on the market, is to include metering also in the construction, in the initial construction. So this box is provided together with metering, but it also includes the necessary temperature, pressure, and mass flow meters necessary for a continuous monitoring of the and a punctual control of the single components. Therefore, basically, what the building manager or the Annexco company would be allowed to do in this case is to also go through a continuous commissioning of the system, optimizing the performance of the single components, optimizing the distribution of the fluids through the building, and also check eventual faults, therefore intervening before the fault is notified by the user itself. Here in the big picture on top, you see 4 of these energy hubs that are used to connect the different components of the system. So heat pumps and solar thermal collectors to the storages installed in the technical room, and used to distribute the warm and cold fluids into the vertical pipelines I showed to you earlier before. And here you see the same kind of boxes used on each floor to distribute cold and warm water to the single dwellings. So we use 2 of these for each of the dwellings, because we need to distribute cold in summer and domestic hot water at the same time.
Roberto,
I have almost finished. I have one page, one slide yet available to be shown. Inside the dwellings, what we used is to distribute cold and warm water for space heating and cooling, is to use these again prefabricated radiant ceilings that also include LED luminaires, and that are dry mounted on the floor, on the ceiling itself. Therefore, basically, again, this was one of the main concerns in the project. What we did is to install these elements while the tenants were living into the dwellings. And again, we retrofitted 1 dwelling per day, so to say. So 1 dwelling per day to retrofit or to install these radiant ceilings in 6 rooms, 5, 6 rooms, depending on the dwelling. Again, this is before and after retrofit. You can see here on the south-facing facade the solar thermal collectors installed, and again the lift shaft with the pipelines, with the shaft for the pipelines installed. Just to conclude briefly, some lessons learned, and this is also to raise some discussion later on in the last 10 minutes. What we learned through this installation process, or through this design and installation process, is that the installation is very short, but the design is very long compared to a traditional retrofit process. And this is because the integration of different technologies into the same action brings the different actors, architects, energy planners, owners, and so on and so forth, to work together, which is not the case in traditional solutions. And again, this requires that there is a quite well-structured coordination among all the actors involved. Otherwise, the design process does simply not work, or it takes too long. Second lessons learned is that despite we made available prefabricated solutions to the installers, for them it was still very much complex to not to install physically then, but to have them working. So to commission them. And this shows that we need quite a lot of training at European level, mainly mainly at installers level, to make to enhance their skills, to allow them to work, to move from the traditional systems into a new way of working or operating. Finally, and most important in my opinion, is that when you go through this kind of retrofit measures, it is not only, it is never only an energy retrofit. Therefore, the payback of the action should never be weighted only on the energy savings. As I showed before, we renovated the two buildings not only from the energy point of view, but also from the structural and from the architectural point of view. Therefore, again, the value and the economic value of the property is completely different compared to the situation before. And again, this should be somehow weighted when a retrofit action is to be undertaken and is to be discussed initially with the owners of the building itself. As this could be really much convincing for them to again go for the retrofit action. That's it from my side. I was very much longer than what Anne-Claire allowed me to do, but I think I brought some possibly interesting points to be discussed, and so I'm open to your question now.
Okay, thank you very much, Roberto, for this deep presentation. So I open now the floor for questions and comments from the audience. So if you have anything to say, just raise your hand. You have a button for that on your screen. No. We have a question. Yes, Sandrine and Francisca, you have a question?
Yes, hello, this is Francisca from Steinberg Europe Center. My question is regarding the training for the installers. Is that part also of the project activities, and how will this be continued now that the project is closed?
No, that was not part of the activity in this project. We tried to work in close collaboration with the installers on the two construction sites in order to teach them how to make it, which took quite a lot of time. This training staff is missing in the project, was one of the weak points, in my opinion, in the project, and what we would like to have more developed in other European projects that we are writing so far. And in my opinion, it should be also the European Commission trying to promote this kind of project strictly devoted to training of installers.
So it might be actually relevant for the Erasmus Plus program that is running in parallel to Horizon 2020.
Yes, but that is mostly, to my knowledge, Erasmus Plus is for, say, already trained people, so with a master. I'm more talking about plumbers and electricians that should know how to make it. And for this, in my opinion, there should be quite a wide, say, campaign moving from the European Commission down to local, down to the national and local authorities promoting this kind of trainings. So I do not know what is the best, the best framework to do so, but yeah.
Okay, thank you.
Thank you.
Yes, thank you.
Any other questions? Yeah.
I have a question.
Yes, Jürgen, please.
How are the costs of the two solutions shown compared to what was funded by the project and what was funded by the owners? And I think if I compare the two solutions in Ludwigsburg, the new look is not very nice compared to the old look. I think there must be an improvement in the architectural look.
Yeah, this is something I don't discuss. There was an architect who decided to go for this in this direction, so it is not my field nor my expertise, so I don't want to comment on this. I can comment on the cost. The cost of this prefabricated solution in Ludwigsburg was, in my opinion, a little high, in the range of the new of a new construction, so more than 1,000 euros per square meter. On the one hand, because this is a small building with a lot of facade, therefore a lot of a very high S/V value. Therefore, the facade is quite well impacting on the total cost. On the other hand, because we wanted to experiment many ventilation solutions, many different ventilation solutions, that made the cost rising quite a lot. Wohnungsbau Ludwigsburg co-funded 50%, almost 50% the renovation compared to the on top of the European Commission funding. If we go to Madrid, the retrofit is a little more standard if we forget this heating and cooling system, which is not quite common in these popular neighborhoods. The costing is in the range now of 500 euros per square meter, so not really much high. And when we go on the market with these boxes, we think we can go down to 300, 350 euros per square meter. Again, in this case, I'm not quite sure of the co-funding share. I think it was more in the range of 60-70 public funding and 30% single owners funding.
Thank you.
For you to know, again, a normal retrofit measure or a normal retrofit of these neighborhoods is in the range of 200-250 euros per square meter. Only envelope and windows retrofitted. So we added something like 100-150 euros per square meter on top of this, only for the heating and cooling system.
Okay. Is there any other comment or question? Otherwise, we can close the question and answer.
I have another question. Was there a monitoring phase after the before and after the measure? And what was the result for the real energy savings?
Yeah, we were quite late with the demonstration phase, so we could monitor for something like 1.5 years, 1.5 winters, so to say. So we have quite a good understanding of the consumption in the two buildings, which is quite lower compared to what we expected. And this is in Madrid, because people used to have their apartments at an indoor air temperature quite low, in the range of 18-19 degrees during winters. So the energy demand decreases. This somehow is related to the energy poverty issue in these areas. In Ludwigsburg, it is lower compared to expectations, again, because they used to live in quite a lot of people, and again, some retrofit happened already in the 80s, during the 80s. So in both cases, we started from a space heating demand in the range of 80, say, to make it easy, 80 kilowatt hours per square meter a year, compared to an average calculated in Europe, or even from the literature in Europe, which is 150, 130, depending on the climate. The consumption after retrofit, we have only some partial information, because as I said, we couldn't monitor the entire winter. We think, however, from extrapolation, that we can reach the goal of 50 kilowatt hours per square meter near primary energy consumption, or including all, so space heating and domestic hot water in Ludwigsburg, space heating and cooling and domestic hot water in Madrid. So we are in the range for space heating demand of 20 kilowatt hours. So for you to know, again, to make it easy, we move from 80 down to 20 space heating demand. And we are going to monitor again for the next winter, even though the project is finished.
All right. So I think we can close now the interactive session. Thank you, everyone. I will now stop the presentation for you, Roberto, and I will give the floor to my colleagues from Steinbase for a short conclusion. Franziska and Sandrine, you have the floor.
Yes, thank you. It's me, Franziska. Okay, we would like to just briefly highlight a few more activities for you that we are offering in the context of the EeB-CA2 project. So on the one hand, on November 17th to 18th in Brussels, we will have the ECTP conference, and you are invited to promote your innovations there in the booth. The details of this offer, you can see it here on the screen. And if you would like to apply, you can on the one hand click on the link, or also contact you and Claire, right?
Yes, that's it.
Okay, very good. Also in the context of the ECTP conference, but independently of that, so you don't need to actually register for the ECTP conference to attend the matchmaking event that we are offering. It's dedicated to energy efficient buildings. It covers actors from the whole value chain of energy efficient buildings. So we are also trying to find some investors, for example, or some financial bodies that are going to attend it. And it offers you the chance to pre-book bilateral meetings. We have opened the booking session yesterday. So from now on, you can actually, once you have registered, click on the profiles of the participants and invite them to a bilateral meeting to discuss any type of collaboration you would like to initiate with them. So this can be for a new project proposal, for technological cooperation, or basically just a business cooperation. So everything is possible. So take this chance. If you're already registered for the ECTP conference, please register here in parallel, because we are going to ask you to upload a profile of you where you can basically present the organization you're working for, and you can also upload cooperation profiles or requests that you have. And you can do so until November 14th. We are also offering, in the context of EeB-CA2, a coaching service, which is the innovation assessment. This is possible to be implemented individually with the different project partners that are part of a EeB project. It can be a closed or a running project. And in this innovation assessment, we help you to assess the potential of your innovation strategy and the capacities that you have internally in order to successfully bring innovations to the market. So if you're interested in this coaching or assessment, you can contact me, and we will send you this template and also give you then an analysis of this template, and we'll provide you a report with our findings and tell you about the strengths and weaknesses of your innovation strategies. If you haven't done so, please feel free to join the LinkedIn group, which is called the ECTP Energy Efficient Buildings Committee. We have almost 800 members by now, so it's really the contact group where you can exchange on ongoing activities of your projects. If you have activities that are also relevant for the community, so if you have, for example, some public events, feel free to publish them there, as well as if there's a public deliverable, you can just write a short article here or publish newsletters and also initiate technical discussions. So if you haven't joined, please feel free to join. It's really a good way to stay updated about